And one of the things I noticed when doing some research on the problem space that y'all are trying to solve, in addition to my own experience with it, was on your Y Combinator page. There's the video from John from Asianometry, which if I'm
Hmm.
sure most listeners are already watched this channel because it is
Great
absolutely
channel.
wonderful. But John goes through and describes kind of like this verification gap, and I thought it was really interesting the framing, and I'm curious kind of like how y'all play into this. It was I think in 1997 there was this concern about that chip manufacturing right was progressing at such a rate and the development tools were not keeping up with it.
Hmm.
And so like the productivity was lagging. So essentially we'd be able to manufacture devices or silicon, right, that was more capable than we could actually produce with the tooling that we had. And he goes into a number of different reasons for why that wasn't the case. But then verification comes in and becomes sort of the bottleneck in this process. And I'm curious if, why, I guess, verification is the bottleneck there. And if that is the reason that y'all are kind of tackling that as perhaps the first part of improving the development workflow here.
Yeah, I mean, I think so. I think verification has just been overlooked for like a number of reasons. I mean, a big part of it is that it wasn't like a lot of design verification work got outsourced to India and other like lower cost like countries. There's not, and it's also just like not very sexy of a field. It's sort of like you can think of it as like QA, right? Like
Mm-hmm.
like which is not to say that like the work there isn't like super important or like super interesting. It's just that for whatever reason it was like not seen as like an important like field. And if you were graduating with like an electrical engineering degree, then if you worked as like an architect, right, you would get paid like 50% more than if you got paid as a verification engineer. So people in the United States, like, no one graduated like top of their class in electrical engineering and went to work as like verification engineers. And I think that for like cultural reasons, it was kind of like not seen as like that important.
Mm.
Um, yeah, and I do think that like it is a huge bottleneck because people have just like not kept their eye on the ball. Whenever it comes to I think custom silicon, like the amount of custom silicon entering the market right now, and just like exploding, and like people are really trying to like do creative new things with custom silicon, and yeah, I mean and what's like really grinding people down now is like just like this like verification gap, like the productivity just like hasn't kept up, and I don't know, the entire industry in general hasn't innovated that much recently because like I just think that also like there's like a big gap of people. There's kind of like a lost generation of people who stopped doing electrical engineering in I don't know like 2008 to like a few years ago maybe because that's like software engineering uh, like software engineering salaries like exploded, right? But like hardware engineering hasn't kept up.
Mm-hmm.
I think people at Nvidia now are like pretty happy though. But
Right.
but yeah, so there's all sorts of like weird like I don't know like economic macroeconomic reasons that like it just hasn't kept up. And I think more and more people are starting to see that it's like a huge problem, right? I believe like Intel keeps like delaying certain like new chip architectures or whatever because basically because of verification. They keep like finding like little bugs that like get introduced and they can't. They have to like they have to just like I don't know bring a slightly newer version of like an old architecture. But yeah, and I hear that like NVIDIA's like DV like workflow is like very good, so that's like one reason why they've like done so well. So I think more and more people are going to start seeing it as like a competitive advantage to have like a really great verification workflow. Yeah, I mean like startups like have like tons of verification engineers, and it's like a huge overhead for them. And people want to be making new chips. Like it'd be really cool if like you know uh, if you just have an idea for a chip, you could like spin it out in like a few quarters or something.
Right. Right. So in terms of like what is literally the bottleneck, I know y'all are focusing on it. It seems like to me
Hmm.
at least, kind of like collaboration features, and then perhaps just like compute as well, right? Because
Yeah.
y'all are hosting the compute in which the verification runs.
Hmm.
Are those kind of the major aspects of what is causing the bottleneck right now? Or are there other aspects of verification that y'all are tackling or want to tackle in the near future?
Yeah, I mean, like the immediate term, like we're focusing on like collaboration and like compute because uh like a lot of times like in chip design, like tests will like take like days to run. Like sometimes like they're week plus long tests, and just getting those numbers down would be like pretty helpful, I think. But also collaboration is like still pretty primitive. There's a lot of a lot of times like the state of the art involves like copying over a waveform to your coworker or taking screenshots or like sending a Microsoft Word document in an email. Um, it'd be better if like you could just like tag people directly where like the issues are and be able to like debug like within like be able to send links instead. So that's kind of like one of the big things that we're working to enable. And yeah, in the future, like I mean, this is something that we're also actively working on. It's just like helping people write test benches quicker. You should be able to go from like a spec of the chip to like just even like a list of like edge cases like really quickly, or like things to test for, things to make sure that you cover. Whenever two things are integrated, it'd be cool to like just be able to like inspect like those two blocks and like see like potential interactions that could go awry. And that'd be especially useful because like a lot of times like these integration tests like they're like two teams that work on like two different like blocks, right? And you need to integrate them, and like each has like their own domain knowledge of like the block, but it's hard to like transfer that information around. So that's also like a collaboration thing as well. So yeah, I mean, I think there's like a lot of like kind of low hanging fruit, but also there's a lot of like potential innovation that you could just have in terms of like improving people's like productivity. Yeah.